Hello, Assalamualaikum, and thank you so much for having me here today. I am delighted and I'm so happy to be sharing with all of you, especially our panel, Ms. At-Tasneem, Dr. Fadzil Faisae, and Dr. Hadi. My name is Wan Ifan Hafizi bin Muhammad, and I'm here today to talk to you regarding our proposal presentation in subject integrated design project. Our title name is Design and Development of Three-Wheel Electric Scooter Chassis, which are supervised by IR Dr. Fadzil Rahman. Our group has 4 team of members, which are Muhammad Zunakim bin Rahman, Muhammad Shakir bin Abdul Aziz, and Muhammad Faris bin Nordin. For the introduction, according to the Department of Environment, the Malaysian Air Pollution Index, or known as AP, is increasing rapidly for the last 20 years. The result of monitoring indicate that suspended particulate matter (SPM) or nitrogen dioxide are the predominant pollutant. Other pollutants are also observed in several big cities in Malaysia. The air pollution comes mainly from land transportation, industrial emission, and open burning sources. Among them, land transport contribute the most to air pollution. Fine particulate soot threat to human health by penetrating into lungs and will cause lung irritation and weakens our body defense against respiratory disease such as influenza and COVID-19. Okay, regarding the problem that we faces during our discussion, firstly, we have to determine what type of material that is suitable for making our chassis system, which is we have to use the strongest material to use as the body chassis, and then the second is as you all know, conventional three-wheel scooter are not environmental as they use two-stroke Daihatsu engine and very noisy in the street or in the cities. And lastly, usually three-wheel scooter, which are internal combustion engine, are not energy efficient as they use fuel, as not as yes they use fuel, and as fuel is not as green source of energy, thus is making it such not as efficient. Two-stroke engine emit high soot emission. By converting to the electric, there will be no tailpipe emission. Running electricity will reduce the carbon dioxide emission by 60% compared to running petrol. Okay, regarding to the objective, firstly, we want to determine the most suitable material used to develop the chassis. We select the best material that can give low cost but high in quality. Secondly, we want to design and fabricate a high-quality custom three-wheel electric scooter chassis by joining a go-kart chassis and a motorcycle fork within 14 weeks. And lastly, we want to test the operation of the electric scooter chassis functionally using brushless motor power on the road from 0 until 20 km/h. That is our target for first. And then for the scope of the project, firstly, the three-wheel electric scooter design chassis must be designed using SolidWorks software or using Autodesk Inventor. Basically, our group have done this part by using SolidWorks software, and will be shown on the sketching later. And next, we will run the simulation for the stress and strain in finite element method (FEM) by using Autodesk Inventor or Nasrul or using SolidWorks. This FEA analysis is important to contain information the highest stress and strain on each parts of the chassis. Okay.
Assalamualaikum, my name is Mohd bin Rahman. My ID number is MH17035. Okay, for my part, I will present three parts. which is methodology, Gantt chart, and motor calculations. Okay, for the project planning, we start the project with the problem statement, literature review, sketch design. If our design was rejected, so we must do a modification. If our design were approved by our SUV, we continue with the screening, scoring method, design selection, material selection, fabrication, and finished. Okay, the next is a Gantt chart. Okay, for our project, the duration is 14 week, and this is the detail of the project. Okay, week 1 we create a group, week 2 we select a title, week 3 we do a research on the title, week 4 until week 6 we produce the design ideas, week 5 until week 6 we select a design, and week 6 we discuss of the material. At week 6 and week 7 we write the proposal, and at week 8 we present the proposal. At week 7 until week 8 we should make a material selection, and week 7 until week 9 we should make a purchase material. Week 7 until week 10 we construct and fabricate the model. Week 10 and week 11 we test the project. Week 11 we make an analysis. The duration week 11 and week 13 we write the report. At the week 14 we do a final presentation. Okay, next is the motor calculation. Okay, the calculation of the DC motor, the most important value is motor constant K. Okay, K is the combination of the stator size, winding, and the magnetic field. Okay, the torque and the angular speed or rotational velocity are related to the K. Okay, this is the K formula, which is K equal NBLD. N stands for number of turn of wire on each tooth of stator. B is remnant flux magnet. L is length or thickness of stator. D is the diameter of stator. After we get the value of K, we use this formula to find the rotational velocity, and then we can find the torque value using this formula. T equal K times I is the current. Okay, in this case I can find the value of NBLD, so we proceed with another calculation. I choose a motor ZY1016 with the power 350 watt. The speed is 2750 rpm, and the voltage of the motor is 24 volt. Current is 30.5 ampere. The motor weight is 2 kg. So the specification of the motor we can use to find the angular speed and the torque. We use angular speed formula, omega equal to speed times 2 pi over 60. So we get the value is 287.98 radian per second. We find the torque. Torque is equal to power over angular speed. The power we have here is 350 watt over 287.98 radian second. So we get this value of the torque. That's all for me. Thank you.
Assalamualaikum. So before I start concept design, I will introduce myself. Okay, my name is Muhammad Faris Benuddin. So this is our first concept design. So this concept I take from ATV, which has 4 tires. Since we want our vehicle in 3 wheel, so we make it 2 tires at the front and 1 tire at the back. So there is some advantage on this concept design. it is more stable and it is suitable for 1 or 2 person at one time. So the disadvantage of this concept design is it's harder to build because it uses more material. When we use more material, we will use more cost. So this concept design may not suitable. So next we go to our second concept design. So we make this concept design more lower because we want to get lower center of gravity, which can increase the stability of our vehicle. So there is some advantage for this concept design. It is the advantage is suitable for 1 or 2 person, and this this concept design is easy for maintenance. So the advantage is this concept design is harder for the user to use because it is very low vehicle, and this vehicle is not suitable for road because we need a high vehicle on the road to make other vehicles see us. So we go to third concept. Okay, this model is better from another model before. It has high and very suitable for person to use this since it is not short and too high. So this you can see this concept design looks more stable. Okay, next we go to our design analysis. So this is our design analysis. We put some criteria that we want for our concept of selection. So we bookmark for each our concept, which you can see the plus for 1 mark and the minus for -1 and 0 marks. So at the end of the analysis, you can see a total mark for the third concept is the highest, which is 2. So we take our third concept design as our concept of selection. Thank you.
Okay, my name is Muhammad Shakir bin Abdul Aziz. My matric number is MH17032. Now I will proceed. The presentation is about bill of material. A bill of material is a list of the raw material, sub-assemblies, intermediate assemblies, sub-component parts, and the quantity of each part needed in manufacturing of end products. The table below shows bill of material, which separate into 3 types, which is mechanical parts, design process, and electrical parts. For the first is mechanical parts. We have 10 mechanical parts. First is swing arm. Quantity is 1. Type of material is mixed steel. Manufacturer at workshop FKM. Second is handlebar. Quantity is 1. Type of material is mixed steel. Manufacturer at workshop FKM. Third part is tire bearing. Quantity is 4. Type of material is steel. Manufacturer at workshop FKM. Next part is rim. Quantity is 3. Type of material is aluminium. Manufacturer at workshop FKM. Next is front shock absorber. Quantity is 2. Manufacturer at workshop FKM. Then a rear shock absorber, also quantity is also 2. Manufacturer at workshop FKM. 7 part is tire. Quantity is 3. Type of material is rubber. Also manufacturer at workshop FKM. And then is motor bracket. Quantity is 2. Manufacturer at workshop FKM. Okay. Then is bolt. Quantity is 26 bolt. Type of material is mixed steel. Manufacturer at workshop FKM. 10 parts, and last part of mechanical part is nuts. Quantity is 26. Type of material is mixed steel. Manufacturer at workshop FKM. Okay, now we proceed to the next part is design process. We have about 6 parts and process. For the first is main frame. Process is cutting and welding. Next is for the front fork. Process is cutting and welding also. For the absorber, we don't have process. Then next part is swing arm. Swing arm we cutting, drill and welding for the process. Next is tire shaft. For the tire shaft we cutting. Then is for the handlebar. Handlebar the process is cutting and welding. Okay, next we proceed to the electrical part. We have 6 electrical part in bill of material. For the first part is battery. Quantity is 4 battery. Manufacturer at workshop FKM. Second part is battery charger port. Manufacturer at workshop FKM. Next is wire. Quantity is 1. Manufacturer at workshop FKM. Then is power switch. Quantity is 1. Manufacturer at workshop FKM also. Connector. Quantity is 4. Manufacturer at workshop FKM. Then is motor. Quantity is 1 motor. Manufacturer at workshop FKM. Okay, now I will proceed to the discussion. First is third concept is selected as the final design for fabrication and simulation. Many errors and problems during this project to get a simulation of the model. Based on metric charts from finalized concept, design concept number 3 has the highest rating of effectiveness. Third concept is selected as the final design for simulation and fabrication. Okay, for conclusion, the objective of this project was successfully achieved. 3 conceptual design has been generated. Design number 3 has been selected due to its advantages. This project helped us to understand more about how the concept design selection and also method use. This project had understanding on ankle joint motion, structure and injury. This project teach us how to apply all engineering concepts that we learn in study. The project follow the project planning. Friends, okay, that's all from me. Thank you for hear our presentation.